Alluvial channels form a balance over time between slope, flow, sediment supply, and channel roughness. If one component changes, then the balance tips into either an erosional or depositional phase. When these factors remain relatively constant, we typically see low rates of river adjustment and stable and healthy river system. Many rivers around Australia have seen widespread channel change within alluvial reaches since European settlement. There are a number of reasons for this, including catchment vegetation, which helped infiltration and slow down runoff, was removed for timber and pasture. This increased the flow in our rivers, creating more stream power and erosion of the channel. Riparian vegetation was removed along our rivers and streams to move floodwaters away faster. This increased stream power, reduced the strength of the banks, and increased riverbank erosion and changed channel geometry. Meandering rivers were straightened to move floods through quicker, which resulted in a large increase in channel slope and, therefore, stream power. Increasing stream power resulted in the erosion of the bed and banks of the river. Sand and gravel was extracted from the rivers to support construction industries, which reduced the supply of sediment to downstream reaches and increased the slope of the upstream supply reach, increasing available stream power and causing erosion of some of the bed and banks both upstream and downstream of the extraction area. Removal of riparian and catchment vegetation, straightening meandering streams, and sand and gravel extraction all contribute to increasing the stream power during flood events. All these activities contribute to river instability, causing bed lowering, channel widening, and loss of in-stream variability. Lowering of the riverbed causes bank instability and the channel gradually widens. This means the river can hold more water during floods, instead of spilling out onto the floodplain, and therefore becomes faster and more destructive. As the channel deepens and widens, adjacent land is lost. The flow and effects of river alteration can last for many decades and recovery can be very slow. The deep pools, bars and vegetation, which provide important areas for aquatic plant growth and habitat for our native animals like fish, turtles and platypus, are lost. So how would we go about improving damaged rivers so they are more stable during high flow times and support our communities and natural environment? Well, every stream is different. However, there are some core principles we can apply. A messy river is a healthy river. Logs, trees, and shrubs all provide friction within the channel, which helps slow floodwaters down. They also provide fantastic habitat for our native animals and keep the water cool and clean. They can also support abundant life in all forms, from microbes to vertebrates, and maintain critical chemical and physical processes. Yes, it means floods may stay around a bit longer. This can cause a quandary for some. Overall, the benefits of slow water outweigh the ravages of fast water, which can cause devastating erosion and increase flooding downstream. The most effective way to reduce flows, with the added benefit of providing bank strength, is by reinstating trees on the banks in the upper catchment. Planting native vegetation is critical to stabilising our river systems, but not just one type of vegetation. We need a range of different species that all play a different role. Large trees with their deep roots, shrubs and small trees which have lots of branches and foliage that help slow the floodwaters down, and our native grasses and ground covers to lay flat in floods and protect the underlying soils from the fast flowing water. As we saw in episode 1, trees, Shrubs and ground covers need each other to form an army of strength against the energy of floodwaters. We need to plant a variety of plants so that each type can contribute in their specific way to the overall outcome. Our rivers are so important to our economy, communities, and environment. There's a lot we can learn from river management in the past, when decisions were made without understanding the broader catchment-wide context of our river systems. It's important for all of us to understand key river processes and the values rivers provide to us so we can effectively manage our rivers and streams into the future and avoid costs of land loss and poor water quality.